Imagine a world where the speed of light is no longer a barrier. Where distant planets are just a short trip away, the vastness of space seems suddenly smaller. This is the promise of light-speed travel, a dream scientists and engineers have been chasing for generations, but until now it has remained just that, a dream. That is until Elon Musk publicly announced that NASA has finally built an impossible speed engine. Elon Musk's announcement changed everything we thought about light-speed travel. What could this mean for the future of space exploration? And what other impossible technologies might be just around the corner? If you want to learn more about light-speed travel and the implications of this groundbreaking announcement, keep watching to learn everything about the new light-speed engine and what experts are saying. Regarding space exploration, one concept that has always fascinated scientists and dreamers alike is the idea of traveling at the speed of light. The notion of light-speed travel conjures images of zooming through the cosmos, reaching distant galaxies in the blink of an eye. To understand this, we will need to start from the most basic thing. What exactly is light-speed travel, and why is it so significant in the context of space exploration? Light-speed travel refers to the theoretical ability to move through space at the speed of light, which is approximately 299,792,458 meters per second. A spaceship could traverse immense cosmic distances at this incredible velocity in remarkably short time frames. For instance, a journey that would take centuries with current technology might be accomplished in just a matter of minutes. The concept is alluring because it offers the promise of exploring distant celestial bodies and unraveling the universe's mysteries in previously unimaginable ways. Einstein's theory of relativity, introduced in the early 20th century, fundamentally changed our understanding of space, time, and motion. It consists of two parts: the special theory of relativity and the general theory of relativity. The special theory, published in 1905, laid the groundwork for concepts such as time dilation and the famous equation ELMC2, which relates energy and mass. This theory revolutionized the way we think about the universe. One key principle of the special theory of relativity is that the laws of physics are the same for all non-accelerating observers. This means that the laws of physics, including those governing the speed of light, are constant for all observers, regardless of their relative motion. It also introduced the idea that as an object approaches the speed of light, its mass increases and time slows down relative to an observer at rest. Prominent figures like Elon Musk have also tried their hands at conquering the seemingly impossible notion of achieving light-speed travel. Musk, the visionary entrepreneur behind SpaceX and Tesla, is no stranger to ambitious projects that push the boundaries of science and technology. While light speed, as portrayed in science fiction, remains a distant dream, Musk's endeavors have focused on more achievable goals, such as space travel and the advancement of electric vehicles. Nevertheless, his ventures have contributed significantly to our understanding of the possibilities and challenges of traveling at the speed of light. SpaceX, one of Musk's most renowned ventures, has made remarkable strides in the field of space exploration. Although the concept of achieving light speed within our lifetimes remains far-fetched, SpaceX has made space travel more accessible and cost-effective. By developing reusable rockets and pioneering the concept of private spaceflight, Musk has significantly reduced the cost of reaching orbit. While not directly related to light speed, these efforts are essential steps in making space travel more efficient, a prerequisite for any interstellar ambitions. The Hyperloop, another visionary project Musk has been associated with, was conceived as a high-speed ground transportation system. Though not a light-speed technology, the Hyperloop demonstrates Musk's fascination with rapid travel. The concept involves a network of low-pressure tubes through which passenger pods could theoretically travel at near supersonic speeds. While the Hyperloop has faced technical and financial challenges, it represents Musk's ambition to redefine transportation on Earth, showcasing his commitment to pushing the boundaries of what is possible in terms of speed and efficiency. Musk's Tesla electric vehicles have also contributed to a more sustainable and technologically advanced future. While they don't travel at light speed, they have become pioneers in the electric vehicle industry. The development of powerful electric car batteries and the proliferation of charging infrastructure have been critical components in reducing carbon emissions and promoting cleaner transportation. These innovations are important for addressing the ecological challenges we face on Earth and can serve as a blueprint for environmentally conscious technology on a broader scale. In the context of space exploration, Musk's vision extends beyond our immediate environment. He has spoken about the colonization of Mars as a potential solution to humanity's long-term survival, especially in the event of a catastrophic event on Earth. While practical light-speed travel remains a distant dream, Musk's ventures have significantly contributed to the broader fields of space exploration, high-speed transportation, and sustainable technology. These areas of innovation have the potential to lay the foundation for future generations to explore the realms of physics and engineering necessary to unlock the secrets of light-speed travel. But there's a catch. Challenges and impossibilities associated with achieving light-speed travel are grounded in these principles. First, the immense energy requirements to accelerate a massive object to light speed are beyond our current technological capabilities. Second, as an object approaches the speed of light, its mass increases, further escalating the energy needed for acceleration. These limitations pose practical challenges that appear insurmountable with our current understanding of physics. However, faster-than-light travel has captured the imaginations of writers, filmmakers, and enthusiasts for generations. Science fiction has often depicted this dream in various ways, such as warp drives in Star Trek or hyperdrives in Star Wars. These fictional technologies allow characters to achieve faster-than-light travel, creating vast interstellar civilizations and adventures. Despite the challenges that scientists have faced in recent years, organizations like NASA have garnered a well-deserved reputation as pioneers in the field of space technology. For decades, NASA has been at the forefront of pushing the boundaries of space exploration. Through relentless innovation and groundbreaking research, NASA has not only explored our solar system, but has also set the stage for ambitious missions to distant planets and beyond. NASA's expertise in designing spacecraft and propulsion systems has been instrumental in advancing our understanding of the cosmos. From the Apollo moon landings to the Mars rovers, NASA has consistently demonstrated its commitment to advancing human knowledge and exploration. Amidst this situation, David Burns, a NASA engineer, has, in his leisure hours, continuously embarked on an audacious quest to find a solution to some of the challenges faced by the organization. As a devoted member of the NASA team, Burns understands the complexities and limitations of current space technology. This understanding has fueled his determination to contribute to the field of space exploration. Burns' personal journey began with a simple but profound question. How can we make space travel more efficient and cost-effective? This question has plagued space agencies worldwide for years. Traditional rocket propulsion systems are not only expensive, but also have significant limitations in terms of fuel efficiency and speed. It's a puzzle that has perplexed scientists and engineers for generations. But thanks to Burns, it is about to become a thing of the past as he has conceived an unconventional engine design that he boldly claims can achieve velocities up to 99% of the speed of light. The most astonishing aspect of his invention is that it purportedly doesn't require any propellant to function. This groundbreaking idea, dubbed the helical engine, now resides in the annals of NASA's technical reports server, though it has yet to withstand the scrutiny of peer review. Unsurprisingly, this revelation has generated immense intrigue and fascination, reminiscent of the fervor seen during the early days of the EM drive. Speculation and whispers abound, with some stories even suggesting that the helical engine might have the potential to break the rules of physics. But before we delve into the nuances of these revolutionary concepts, it's essential first to comprehend the foundation upon which they are built, beginning with a closer examination of the enigmatic EM drive. The EM drive, standing for Electromagnetic Drive, represents NASA's initial exploration into the daring realm of crafting engines capable of achieving faster-than-light travel. The concept of the EM drive, which some people call the impossible drive, was first introduced by Roger Scheuer, a British chartered electrical engineer with extensive experience in the space and defense industries. Back in 2001, Scheuer proposed the EM drive as a radio frequency resonant cavity thruster that could potentially revolutionize spaceship propulsion. The core idea behind the EM drive is truly revolutionary, and it challenges well-established principles of physics, particularly the law of conservation of momentum. This unique propulsion system is claimed to generate thrust by internally reflecting microwaves, seemingly defying the laws of physics as we understand them. Hence, it's no wonder the media has often called it the impossible drive. The explanations for how the EM drive could function take us far beyond the limits of our current understanding of physics. Some theories suggest that it might interact with the vacuum energy of space quantum time, even though this form of energy doesn't allow anything to push off of it. This raises intriguing questions about the nature of momentum and whether this concept ushers in a new era of physics, challenging our fundamental principles. What makes the EM drive even more unique is the absence of an official design or a comprehensive explanation of its operation from its alleged creators. Without a detailed breakdown of how this thruster functions and what components constitute it, it becomes incredibly challenging to identify genuine EM drive devices in the wild. One of the notable moments in the EM drive's history occurred in 2016 when NASA's Advanced Propulsion Physics Laboratory reported observing a small apparent thrust in one of their tests. This result sparked significant excitement, but it has not been replicated since. Subsequent studies have raised doubts about the initial findings, suggesting that the observed thrust might have been influenced by factors such as interactions with the Earth's magnetic field or thermal gradients. In March 2021, scientists from the Technical University of Dresden published 3 papers debunking the notion of the EM drive. According to their research, the thrust generated by the device was simply a fluke, explained by external forces rather than a groundbreaking propulsion system. While the EM drive has garnered a great deal of attention and intrigue, it's essential to remember that there is no conclusive evidence to support its validity as a functional spacecraft thruster. The scientific community remains divided, with some dismissing it as a scientific curiosity. Now, let's shift our focus to the man of the day, the helical engine. While it carries its own sense of intrigue, it, too, faces skepticism from various quarters. As David Burns proposed, the helical engine presents an innovative approach to spacecraft propulsion. This idea revolves around a novel way of generating thrust that, at first glance, seems to challenge the laws of physics. Burns suggests that the helical engine could potentially allow spacecraft to achieve continuous acceleration without the need for propellants. The concept involves a spacecraft with a central, rotating, massive disk. By manipulating the rotation of this disk and exploiting the principles of conservation of angular momentum, Burns envisions a propulsion system that could provide continuous thrust. This idea is rooted in a reinterpretation of established physics, which has naturally sparked skepticism and interest within the scientific community. While the helical engine is certainly intriguing, it's important to approach it cautiously. Defying the laws of physics as we understand them today is no small feat. As with the EM drive, the helical engine's claims and ideas require rigorous testing and validation through the scientific method. David Burns, the proponent of the helical engine, firmly believes that his concept is worth pursuing, and it has captured the imaginations of many in the field of space propulsion. However, it's crucial to emphasize that scientific scrutiny and validation are essential in determining such groundbreaking concepts' feasibility and practicality. Burns introduces his idea through a simple thought experiment involving a box with a weight inside, suspended on a line and equipped with springs at either end. In a vacuum, akin to space conditions, this setup results in an intriguing motion. The weight appears stationary, while the entire box jiggles, akin to a stabilized GIF. The crucial aspect of this concept is the ability to manipulate the mass of the weight, effectively altering its direction and creating thrust. However, this may seem to contradict the momentum conservation principle, which states that the total momentum of a system remains constant unless influenced by external factors. Albert Einstein's theory of special relativity further complicates the picture, as it indicates that objects gain mass as they approach the speed of light. In theory, this should hinder the effectiveness of Burns' idea. A straightforward application of his concept would involve replacing the weight and box with a circular particle accelerator, accelerating ions to relativistic speeds and then decelerating them. Nonetheless, Burns assures that the helical engine employs a helix-shaped particle accelerator to facilitate lateral and circular movement. This unique design addresses the challenge posed by special relativity, as it allows ions to move at varying speeds along the accelerator's length. The helical engine operates by accelerating ions confined in a loop to moderate relativistic speeds and then modifying their velocity to alter their mass slightly. This crucial manipulation of ion properties allows the engine to generate thrust. Notably, the helical engine lacks traditional moving parts. It relies on ions traveling within a vacuum, guided by electric and magnetic fields. The concept of successful light-speed propulsion is a fascinating and groundbreaking idea that could revolutionize how we explore the cosmos. It is an exciting prospect that holds the potential to transform space exploration as we know it. To comprehend the implications of achieving light-speed propulsion, we must first understand the immense impact it could have on our society, economy, and even our perception of the universe. Space exploration, especially the dream of reaching distant stars and galaxies, has been a fundamental human aspiration for centuries. The realization of light-speed propulsion would bring this dream to reality. Currently, our spacecraft travel at a snail's pace in comparison to the vastness of the cosmos. Reaching our closest celestial neighbors like Mars takes years, even decades. With light-speed propulsion, these astronomical distances could be traversed in mere moments. This means that distant stars and galaxies, which were once only observable through telescopes, could become potential destinations for future human exploration. From a societal perspective, the implications are immense. The ability to travel at or near light speed could open up the possibility of space colonization. Imagine human settlements on distant exoplanets or moons, completely altering our understanding of what it means to be an interstellar species. These new colonies could serve as a backup for humanity, ensuring our survival in the face of potential planetary catastrophes. Moreover, the potential for resource exploration in space could be a game-changer for our economy. Asteroid mining, for instance, could provide us with access to vast quantities of precious metals and resources, potentially reshaping industries on Earth. The economic consequences of light-speed propulsion are equally significant. It's important to understand that achieving such a technological milestone would require a substantial investment of resources. Governments, private companies, and international collaborations would likely pool their expertise and funding to realize this dream. This could stimulate economic growth by developing new technologies, manufacturing, and job creation, reminiscent of the economic boom seen during past major technological advancements. However, with great advancements come great ethical and philosophical questions. The ability to travel at or near light speed raises concerns about potential misuse or unintended consequences. For example, what would impact the environment if we could readily transport large numbers of people and cargo to distant planets? How would this affect the ecosystems of these celestial bodies, and what ethical responsibilities do we have in preserving their natural state? The philosophical questions are equally intriguing. The prospect of light-speed travel challenges our perception of time and distance. In a universe where we can reach the farthest corners in the blink of an eye, what would this mean for our understanding of space and time? Concepts of relativity and causality would need to be re-evaluated, and new philosophical inquiries would emerge. Moreover, light-speed propulsion could trigger profound questions about the nature of human existence and our place in the cosmos. It may lead to explorations of the meaning of life, the search for extraterrestrial intelligence, and our understanding of the universe's purpose. Ethical dilemmas might arise concerning interactions with potential alien civilizations, with questions about how we should approach contact or coexistence with other intelligent beings. Ultimately, the implications of successful light-speed propulsion for space exploration are profound and multifaceted. From the promise of reaching distant stars and galaxies to the societal and economic consequences, this technological achievement could reshape our future as a species. However, we must tread carefully, considering the ethical and philosophical questions that arise. While the path to light-speed propulsion is paved with challenges, its potential rewards are boundless, offering humanity a chance to unlock the mysteries of the universe and our place within it. How excited are you about this development? Share your thoughts in the comments section below. Don't forget to like this video and also subscribe to this channel for more updates. Thanks for watching.